Hi, I'm Tom Wishon, and thanks again for your interest in golf club technology. Today I wanted to talk about a subject that's come up a lot, in my readings and my observations of what golfers are interested in knowing about their equipment. And that's this topic of, gee Tom, how much better is club head design today than 5 years ago, 10 years ago, 20 years ago? Of course, this is a point of interest because with all the marketing that goes on about golf club designs, the vast majority, in fact, you could almost say 99% of the marketing of golf clubs is done behind whatever technology the company is trying to design into the club head, okay? They're missing a little bit of the boat, from the standpoint that you got a shaft and a grip and 12 very important fitting specifications that need to be matched to each golfer before that club head as part of that golf club can even begin to perform properly for you. But nonetheless, the marketing of the golf clubs is chiefly done on the basis of the club head's design technology. Okay, so is it better today than it was 5-10 years ago? If you've got a 5-year-old driver, a 10-year-old driver, should you be looking at investing in a new one? Okay, the biggest answer to that has to do with not really the club head, but whether or not all of those key fitting specifications, which we're talking about things like the length, the loft angle, the lie angle, the face angle, the shaft flex, the shaft bend profile, the shaft's weight, the total weight of the golf club, the swing weight or head weight feel, the grip size, whether these things actually fit you and your size, strength, athletic ability, and swing characteristics. That's going to determine far more about whether any golf club is going to work better for you, really, than the club head design on its own will, okay? But what we have today, we're really at the nadir, we're really at the apex, of club head design with regard to drivers today. The United States Golf Association has a limit on several things related to driver head design in the rules of golf. There is a limit on the coefficient of restitution, or what they call the spring face characteristic of the face. In COR terms, 0.830. Under the USGA's test procedure, which is called CT, or characteristic time, a measurement of 257 microseconds. Your club head can't be beyond that, or it's not conforming to the rules of golf. Okay? Most all of the companies who are good at designing club heads have been at this or as close to this COR-CT limit in their drivers for quite a number of years now. More than 5 years, at least 10 years, going back. So, will you be able to buy a driver head that has a higher COR and therefore get you more distance from the face design? If you do, it'll be strictly by random, based on plus or minus tolerances of things like the face thickness. Yes, you can go out and just by luck happen to buy a driver head that the face is just a little bit on the thinner side of the production tolerance. From that, you'll get a little higher COR and a little bit more distance. Well, how do you know? Okay, the best way to know if your face design of the driver that you're using or being fit into, the best way you can possibly know if that's maximized as close to the limit in the rules for the spring face characteristic is through a thing coming off of the launch monitor called smash factor. Okay? Smash factor is the ball speed, the speed of the ball coming off the club face, divided by the club head speed that you swung the club to hit that shot. Now, within the physics of face design, we can't have a smash factor higher than 1.495, meaning a ball speed of 149.5 miles an hour and a club head speed of 100 miles an hour. Remember, ball speed divided by club head speed is smash factor. If your smash factor is higher than 1.50, because launch monitors will round up, so 1.50 can definitely be fine. If you see a smash factor like 1.51, 1.53, either one of two things is going on there. One, the launch monitor is not reading the ball speed or the club head speed as accurately as it should. and one was higher than the other to cause that the divided relationship between ball speed and club head speed to be a little bit higher, or the head could be over the limit, and higher than what the actual limit is allowed in the rules. On the other hand, what happens if you hit the ball in the center of the face, where you're going to get your maximum smash factor, and your launch monitor reports that you're getting a smash factor of 1.43, 1.44, for example, with the driver? Okay, again, it could be an error in the launch monitor. Keep in mind that measuring these parameters of ball speed and club head speed is very difficult. And not all launch monitors or golf simulators can measure these parameters with the same level of accuracy. The most reliable in the game today for these measurements are, of course, the TrackMan launch monitor and the Flight Scope, monitor. There are a few others that are reasonably good at this, at GC2, for example. Beyond that, it's kind of a guessing by golly as to whether or not you're going to be getting accurate specifications. Again, not many of the simulators that you see in golf stores, where you have the big video screen you're hitting into to show the ball, these are not real accurate either for ball speed or club head speed. So you can't make decisions in terms of, are you getting the maximum smash factor, and therefore are you in the best driver club head for your swing? The point is, though, if with a TrackMan or with a Flight Scope or with a very accurate launch monitor, if you're seeing smash factors of 1.43, 1.44 with the driver, okay, you're not optimized. There could be a driver head out there with a better face design that can give you that maximum smash factor of 1.49, 1.50. Okay, it's not huge. If you're playing with a driver that has a 1.44 smash factor and you go find one that's 1.50, if you swing the club around 100 miles an hour, you're going to pick up about 3 or 4 more yards. It's not more than that, but it is a little. Point being, though, is that we're pretty much all at the limit of where we can be for the design of the face with regard to distance with maximum ball speed. Okay, one of the big things, though, from a face design standpoint that some companies have gotten better at, especially in the last 10 years, is the design of the face with regard to off-center hit performance forgiveness. Okay, some of you maybe have heard the term of variable thickness face design. What this means is that some designed area in the middle portion of the face is going to be ever so slightly thicker, while all the perimeter areas around it, or going around the edges of the face, are going to be thinner. What the concept is for that is to basically try to make the face flex just a little bit more for off-center hits. So the idea is to design the center of the face area where it's a little thicker, so that you still have your legal maximum COR or CT under the rules of golf, but then by making the outer areas a little thinner, when you hit the ball off center, you get a little more face flexing, which is the key for better spring face or better COR. So off-center hit COR has gotten better in some drivers over the last 5 to 10 years. How do you know this? Again, a couple different things. If you're hitting shots on a Flight Scope or a TrackMan or a good launch monitor, and you use impact labels so you know exactly where on the face you're hitting the shot, if you hit the ball off center and you're seeing a smash factor of 1.47, 1.46, that's really, really good for off-center hit performance. On the other hand, if you hit the ball a ½ inch to 3/4 inch off center with a driver and you see a smash factor of like 1.38, 1.35, not that good of a face design from an off-center hit capability. So again, there's a way that you can use an accurate launch monitor for off-center hits to determine whether the driver head you have is one that is not as good as some that are out there, with much better variable thickness designs. What's another area of change within the driver heads, okay? The moment of inertia, okay? And what we're talking about is the one moment of inertia that's most talked about is the moment of inertia where it dictates how much the head is going to twist when we hit the ball off center, okay? And that is, you put a spike right down through the middle of the head through the center of gravity, somewhat like this, and you hit the ball off center towards the toe or heel, how much does the head twist? How much does the head resist the twisting? In other words, the higher the moment of inertia, the less twisting you'll have, the better energy transfer. In other words, you will reduce energy loss on the off-center hit. You get a little bit more ball speed and distance. Okay, this one's a little bit overblown right now. Not a lot has changed in the last 10 years with this. For one thing, there is a limit in the USGA rules to the MOI of a driver head. It's set at 5,900 grams centimeter squared. Okay, what's that mean? Basically, it means that it's a limit that no one's ever going to achieve. Okay, in a normal playable driver. Okay, and what I mean by that is this. Okay, the USGA also has a limit for the volume and dimensions of a driver head. A driver head can't be bigger in volume measurement than 469 cubic centimeters, okay? Well, it just so happens a driver also can't weigh much more than about 200 to 205 grams. If you make a driver head any heavier than that, at normal fitted lengths, the golf club's going to be having too high of a swing weight. You're not going to be able to play the golf club very well. It just isn't going to be as playable. So all driver heads have to be made within a pretty narrow range of weight as dictated by what length and what shaft weight, what grip weight they're going to be built to, so that they can be of a normal finish swing weight for golfers to be able to swing the club reasonably well. So with a limit on the weight that a driver head can be, with a limit on the size that the driver head can be, within those limitations, it's just not going to be possible to achieve a higher MOI than what we're doing today, with driver heads. And certainly years ago when the MOI limit of 5,900 was established, there was one company that came out with a driver that was said to have right at the limit of 5,900 grams centimeter squared for the MOI. Okay, the way they did that, two things. It was a square-shaped driver, so they had some more weight positioned further from the center of the head, which is key for increasing MOI. But they also made the driver with a very, very high swing weight. In other words, a much higher head weight. Heavier head weight increases the MOI as well. This particular driver didn't last more than a year on the market, quite frankly, because very few people could play it. It was too head heavy. And nobody could really swing the club very efficiently time after time. So it was a head that was made, it was a club that was made just to prove a point that the 5,900 limit in the rules could be achieved, but it was completely impractical. So as a result, you see in most all of the companies' driver heads today, rarely do you run into one where the moment of inertia is going to be much higher than 5,000 to 5,200 grams centimeter squared. So we're at the limit for the MOI. For that. So beyond that, when it comes to a driver head, you see some heads that have movable weights shifting from heel to toe, or moving weights shifting from top to bottom. These are design features in driver heads that really are only able to be perceived in terms of the ball flight change by very skilled, very repeatable swinging golfers. The typical golfer who shoots between 80 and higher up to 100, in moving the weight back and forth from heel to toe or up and down, you're just not going to see any real performance change whatsoever for that. So these are more of what we call superfluous, or their design characteristics which are extremely tiny in their ability to make any real visible change in ball flight and shot performance. So what's that leave us here now that we have limits from the USGA and the fact that companies have been designing on the limits of driver heads for some time? What it means is that the fit of the driver, its length, its loft, its lie angle, its face angle, the shaft and its weight and flex and bend profile, the total weight of the golf club, the swing weight of the golf club, these are all going to be very, very important, and these are what are going to determine whether or not you hit the next driver you buy better or worse than the one you have right now. Is the head design important? Absolutely, because you want to have the maximum of COR with the best off-center hit face, variable thickness face design with the highest MOI you can. All those points, but then if you don't get the length, loft, lie, face angle, shaft, grip, everything else fit exactly right to you, doesn't matter how good the head design is, it won't perform well for you. So the next time you're thinking about new driver technology, don't be grabbed by all the marketing behind the design of the head, okay? Be more interested in finding a really good, knowledgeable, and experienced custom club fitter with whom you can work, who will identify what all of your key fitting specifications are that match to you and your swing, and then to be able to build that driver to have those fitting specs to match you. Do that, and you will end up with the best golf club, the best driver that you've ever played in your life. Again, thanks very much for your interest in golf club design technology and club fitting technology.